Hello and welcome to our webinar, How to Maximize Your Edge Data, Transitioning from Connected Edge to an Intelligent Edge. My name is Jay David. I am the Senior Manager for Solutions Marketing at Stratus Technologies, and I will be your host for the first half of today's session. We are at a pivotal moment in technology where orchestrating applications on a larger scale is now possible. This technology allows to, number one, deploy and control, that is, manage container-based and native edge applications across thousands of distributed locations efficiently. Second, connect seamlessly, that is, integrate edge gateways with any legacy or next-generation equipment, facilitating out-of-the-box IT and OT conversions. And finally, manage life cycles, that is, provision, configure, update, operate, and decommission edge devices with ease, ensuring that they remain secure and operational over the long term. Barbara integrates seamlessly with the Stratus Edge computing platform, creating an industrial-scale orchestration solution. This synergy combines Barbara's capabilities in application orchestration and centralized management with Stratus' operational resiliency, Class 1 Division 2 reliability, and overall downtime protection. Together, they enable customers to maximize their data and transition from a connected edge to a fully intelligent edge environment. Before we begin, ladies and gentlemen, I'd like to invite and inform everyone that today's webinar is divided into two sessions. In the first half, we will take you all into a journey to the intelligent edge and present two customer case studies. First, one on edge computing and digital twin integration, where you will learn about this technology, how it enhances efficiency in a chemical plant. And second, digital transformation of a power grid operator, where you'll find about the successful digital journey of a major power grid operator in Spain. The second session is titled How to Elevate Your Edge Infrastructure, Enhancing Reliability and Scalability with Stratus and Barbara, which is going to be conducted by my partner and collaborator, Miren Sabaleta, the head of marketing at Barbara. Please feel free to submit your questions by clicking on the Q&A button at the bottom of your webinar screen at any time during the webinar. We will address all your questions after the first session, and if time constraints prevent us from answering any of your questions, we will respond to you personally via email. Additionally, this webinar is being recorded and will be made available later as an on-demand resource. We are fortunate to have two distinguished subject matter experts with us today. Let me introduce our panelists. First, Rudy de Anda. He's responsible for strategic alliances at Stratus. Rudy will present that case study we just mentioned from a chemical manufacturing company. Second, David Puron. He's the CEO of Barbara. David will discuss a case study involving the electrical power grid operator. So, ladies and gentlemen, to kick things off, I'm very pleased to invite Rudy de Anda to present the case study on edge computing and digital twin integration, enhancing efficiency in chemical plants. Rudy, over to you.
Thank you so much, Jay. Welcome, everyone, and thank you for attending. Hopefully, everyone can hear me okay. As Jay mentioned, I'm going to go over a few of the details of a project that we implemented that leveraged several different AI models and digital twin technology in order to solve for energy. Energy usage really was the main KPI that we were looking to solve when we looked at this project. And I'll begin with the concept as we look left to right on this chart, the concept that most of us have either plant or enterprise-wide goals. And those goals then need to be implemented all the way down into field devices. And when we're really looking at these goals, in this case, we knew that we wanted to reduce energy by 2% per megawatt hour per metric ton of product that we shipped year over year for 10 years. And so this is a very big picture goal. And we thought, how do we break it down into equipment to achieve that? So we really look from left to right as we look at our plant, all the way down to units and all the way down into assets that are in the field. However, when you're building digital twin models and deploying some of these solutions, you begin all the way down at the lowest level, which are the assets and the measurements that you're recording in the field and controlling in the field. So really your deployment and model building begins right to left as we look at this at these graphics. And when we begin with these measurements, really what we began was with all the historized data of the assets and the measurements that we had in the field. This allowed us to create energy consumption centers where digital representations of units and processes. Ultimately, we built that up into an entire unit. And then we began to look at the dependencies between units and ultimately created a model of the plant. And once we had the model of the plant, in this case, we were able to begin tracking our key metric, which was megawatt hours per metric ton of product produced. A few interesting points that we had in this journey that we learned. First was instrumentation and raw data are the single most important factor in creating high fidelity models. You can do all of the simulation you want, but really everything is anchored in those measurements, the accuracy of the devices that you have, and the more measurements you have in the field, as well as well-organized data, are really the base for you to create good high-fidelity models. The other thing we learned is that it's much faster to begin with generic equipment models that the process engineers provided that were built on known required data. Then you can begin the data science portion of comparing your energy KPIs to all the historized data that you have, which allowed us to then create correlations that we did not know existed. And even our process engineers began to learn a whole lot of insights about the process and correlations that we didn't know that impacted the energy metrics of our site. And what we learned was that many factors actually impacted our energy performance, including the health of our assets, the variations in raw material that we had, as well as the production rates that we needed to manufacture at. However, no matter which factor was causing the inefficiency, the required response time yielded diminishing returns if the operator action was not taken within the first few minutes. And this was the main driver for our architecture, which was an edge-first architecture. If you'll go to the next slide, please. This edge-first architecture, although we knew had to be deployed at the edge for real-time processing because of the diminishing returns, we knew that it was not feasible to develop it and train it all at the edge. So we had the data center portion of our work, and then we had the edge portion of our work where we were deploying it. The project implementation was about 6 months long, and we knew that we couldn't move all of our data engineers to a site for 6 months in order to work on it. So we had to have teams that were working offsite within the data center with the raw historized data. So those teams began with our historical data. Again, very important that that data was labeled correctly, tracked correctly, and and we had good time series data available to us. And beginning with that historical data, we began the offline analytics and model development to create a model that helped us track the energy usage and energy flow through our site offline. And then ultimately we got to that top circle you see there, which was the model deployment. We had a good model that we felt we could deploy off to the site. So we pushed that over to the edge. Once that model was at the edge, we began feeding it real-time process data. And that real-time process data is what guided our operators to give them recommendations as to how they can begin changing the operations of the plant in order to solve for our main KPI, which was energy usage. The operator then implemented the changes into our control system, which ultimately then fed our historization. Now, one of the key points that I want to address that really brought a lot of debate when we looked at this was the connection from online analytics to implementing control changes. One of the decisions we made, if you'll give me a click there, David, is that we decided not to go directly from online analytics and implement that directly into our control system. Our decision at this site was that we would always keep the operator in the middle. Meaning we are going to give a recommendation to the operator, but the operator is ultimately going to make the decision as to whether he is going to take that recommendation. Even though our models wanted and included over a 97% certainty, we knew that there are different factors that were implemented that still a human needed to take into consideration. For example, production rates. Sometimes producing a little slower is a little more efficient. However, we had production rates we needed to make, or asset availability. Hey, maybe the asset that's more efficient wasn't available due to maintenance, or maybe there were safety concerns or different issues that we still needed a human operator in the middle. So really, this was key and is going to be a unique consideration whenever you start looking at implementing any systems within your own site. So obviously, the last part that I'll mention when we look at this project that was a key insight for us was that this real-time process data that we began to track, we needed to close the loop. We wanted 2% reduction of energy year over year. And the only way to create a continuous improvement cycle was to continue to feed that real-time process data to our historical data model on the left-hand side. And then again, go through the loop of doing offline analytics, doing more tuning to our model, and then deploying newer versions of the model. And that's really where technology developments such as what we're doing with Barbara really become key. So I will hand it back over to you there, David.
Thank you, Rudy, for that fascinating digital twin case study and proof positive of the great results of orchestration at the edge. So now, to conclude the first half of our webinar, I want to welcome David Puron, who will talk about the digital journey of a power grid operator from data collection to on-site analytics to ML inferencing at the edge. Over to you, David.
Thank you, and happy to be here with you guys and all the audience on this very, very interesting and relevant topic. Amazing use case, Rudy. So I'm going to give a slightly different perspective. So I will start explaining the infrastructure that we deploy for providing this use case, which is optimizing electricity substations maintenance with Edge AI. So this we did it for a customer which is an electric energy distributor here in Spain, which has a lot of problems maintaining their secondary substations, which is the one that you are seeing here in the screen. So the energy grid is divided, as some of you may know, in primary substations and secondary substations. The secondary substations are the one covering the low voltage, and the challenge is that they are highly distributed. So an electric distributor like this can have hundreds of or even thousands or even hundreds of thousands of substations like the one that you are seeing here in the screen. So many people sometimes ask Barbara when edge computing can provide more value. And there is a simple answer. The more distributed the assets are, the more value edge computing will provide. So if you are speaking, for example, about substations, water treatment plant, large process manufacturing factories, many type of industrial installations that has really, really distributed assets, obviously connecting all these assets to a centralized environment is always challenging in terms of security, privacy, scalability, and putting some processing in the edge close to where the data is can be very, very helpful to digitize those assets very quickly. So Cuerva and Barbara, we decided to go for digitizing these substations using edge computing. So the first thing that we had to do is to put the infrastructure there. So we call it edge computing nodes. And this is the type of infrastructure that, for example, Stratus is manufacturing. In the case of Stratus, is a really, really industrialized infrastructure because it comes with high availability, zero downtime by default. But at the end of the day, you need to put an infrastructure at the edge. So this is an example of a physical node. It could be also a virtual node, or sometimes it could be even a virtual node inside a physical node. So the infrastructure needs to be there. It's important to put the right infrastructure and select the right edge computing nodes so that they are industrialized, like the one that we are seeing in the screen. But then you need to think that you are putting hundreds of nodes outside in the field. So you are moving from a centralized digital environment like the cloud to an extremely distributed digital environment with hundreds or thousands of nodes distributed all over the country. How do you control these nodes? How do you orchestrate the applications that are here? How do you update the firmware? How do you do all these type of things that you normally do in a centralized infrastructure in such a complex distributed infrastructure of thin nodes? For that, you need an edge management and orchestration platform. So Barbara and Stratus provide this edge management and orchestration platform. And from here, you can definitely distribute algorithms and distribute different things. So now you have the infrastructure where you can digitize the operations. Now you need the algorithms, and Rudy was talking a lot about how they developed the algorithms previously in the plant. In this case, the algorithm was developed by the electric distributor because they have the data science capability inside. They have a chief digital officer working with a team of data scientists developing algorithms, and they develop themselves an algorithm that predicts the behavior of the users connected to this substation. So predicting the behavior, they are obviously predicting the demand of energy that they need, but they can also predict the potential failures, overloads, and interruptions of the substation. And this is a huge thing. And I will tell you why a little bit later. But the thing is that this algorithm needs to be trained at the edge as well, because each substation is very different. So part of the algorithm training makes sense for one substation and the substations that are around, but maybe it doesn't make sense for substations that are hundreds of miles farther. So this requires what we call federated training. So part of the algorithm is trained at the edge, part of the algorithm is trained in the cloud. So using Barbara's edge management and orchestration platform, this can definitely be done. You can not only acquire the data from sensors, actuators, but also train algorithms and, of course, deploy algorithms and databases and dashboards to the edge. So this was a very, very successful process, and our partner currently is reducing 85% the number of interruptions and the time that the substation or some of the assets of the substations are interrupted. So this is a huge benefit, and it has a very direct return on investment on the P&L of the electric distributor, because they are subsidized by the government based on the number of interruptions and time of interruptions. So this was a huge benefit for them in terms of return of investment, but this was not a simple trip. This was done through what we call the data journey. So, and this is important that every company can see this journey, and every company can see where they are in this journey. So everything starts with disconnected assets. Everything starts with a lot of PLCs, a lot of SCADA systems, a lot of HMIs, a lot of industrial equipment, which is disconnected. Every industrial company starts from here, right? So the first thing that you need to do is to connect the assets. When the assets are connected to the edge nodes, we always say that the company is in the connected edge stage. For this, in the software that we provide the capability to orchestrate data connectors, and these data connectors are provided out of the box with the platform. So you have connectors for connecting the typical industrial assets using Modbus, OPC UA, Siemens S7 protocol, IC protocols that are very relevant to the industrial, to the electrical world. So with those data connectors, you can basically acquire the data, and you can generate edge databases, time series databases, with very good performance, capable to handle a lot of data per millisecond. But now you need to start leveraging this data. And let me tell you that I think that I saw in a statistic that 75% of the companies are yet in this connected stage. So they haven't been able to make sense of the data. So only 25% of the companies are in the right part of the journey, but 75% are still just gathering data, but without being able to make sense of this data. So the next step is the informed edge. You need to make use of this data. So what we did in these cases is to develop a digital twin, very similar to what Rudy was describing in the previous case. In this case, we were using open source IT tools. In this case, we were using Grafana. They have an enterprise version, which is very useful for being used in enterprise environments. And we managed to create a digital twin of the substation that is providing in real time information from each substation. So this, we call it informed edge. You are informed about what is happening at the edge. But then there is another step, which is control the assets. And this is probably the most critical step, and the step that many industrial companies are very afraid to do because obvious reasons of security. In this case, we managed to control the assets through our orchestration platform using highly secure, only outgoing MQTT encrypted and secure channels with single certificates per node. So there is no need to open any port to the internet. There is no need to create some security hole. Actually, everything is certified using the IEC 62443 security certification. But we managed to control, in this case, the assets of the substation. So we managed to be able to open and close circuit breakers. We are able to change the set points of smart transformers. We are being able to create what we call a reactive edge, an edge that can react autonomously to some of the events that are happening in the substation. And finally, last but not least, one of the most important steps here is the intelligent edge, when you are able to deploy artificial intelligence into the edge nodes, which is the phase where every company is trying to reach, but sometimes it could seem very, very complex. But with Barbara Edge AI orchestration tools, as well as the combination with Stratus edge nodes and edge management system, this can be done in a week's time. So in total, this project of digitizing a whole secondary energy substation and putting an energy prediction AI model took a couple of months, and now it's in production and providing 85% of savings to our customer. So hope this was interesting to you. Over to you, Jay.
All right, thanks, David. That's a really interesting case study on orchestration at the edge. Like I said earlier, if you have any questions, just click on the Q&A box at the bottom of your webinar screens. We have 3 questions right now, and I'd like to ask the first one for Rudy. What happens if you don't have a measurement you need, or if an instrument fails?
Thank you, Jay. So, one of the really interesting unintended consequences that we found through deployment of our digital twin model was our ability to be able to predict with a high level of accuracy what some measurements were based on what was happening around that measurement within our process. Now, this doesn't mean that we were able to, always operate without our instrumentation. However, once we developed a higher level of fidelity within our process, we were able to, for short amounts of time, work with predictions of what those measurements would have been at a really high degree. So, this actually increased the reliability of the site. As we all know, instrumentation fails and maintenance needs to happen. And what typically would have taken down our site, shut down our model, or caused a larger maintenance event was actually we were able to work around it because we were able to predict with such a high level of accuracy and repeatability what some of these measurements were.
Right. Thanks, Rudy. We have 2 more questions. Again, if you have any follow-up questions, just raise them up in the Q&A button at the bottom. Again, for Rudy, can systems like this be developed for waste reduction?
Oh, yeah. So one of the nice things is that really you could solve for any KPI that you'd like. In this case, we were solving for energy. So we were giving operators recommendations on what is the most energy efficient way to run the plant. However, you could solve for several different KPIs that you're tracking, or even multiple KPIs simultaneously. And so, if you wanted to do waste reduction, if you wanted to do safety, if you wanted to do reliability, really, the limit is in making sure that you identify the different modes that impact whatever KPI it is that you're monitoring and want to solve for. You build those models, you feed them with real-time data, and the goal is just to make sure that you have a leading indicator to your control that tracks your KPI. So you could really solve for anything that you'd like.
Yeah, probably for any kind of manufacturing or facility management for that matter. One more question, and then we're going to the second half. This is for David. What would you identify in your case study as the most challenging aspect of the entire project?
I think definitely asset fragmentation is probably the most challenging thing here. As Rudy was describing, with an edge computing project, we can basically track any KPI and you can basically improve any KPI. But for improving some KPIs, you need really data from different set of sources. So in some cases, you need data from an historian or from SCADA, but in other cases, you need also to track real-time data from the assets. So in this case, we were connecting both some of the databases, historians, and OT platforms that were available, but we were also helping the electric distributor to give visibility to some assets that were not connected or were not providing the data at the right time. Yeah.
Right. Thanks, David. Actually, there's 2 more questions, but we have time for one more. Let me ask this. I guess for either for David or for Rudy or maybe both. The question is the edge management and orchestration platform available to be installed on-prem if a customer has the need, and they don't allow to go to cloud, although the internet security is granted?
Yeah, very good questions. I'm glad that this is brought up, because this is very important, and this is one of the main flexibility that Barbara and Stratus can provide. I mean, our centralized management platform can be installed, of course, in SaaS model, also in the private cloud, but we can also deploy the platform fully on-prem, in a small server inside the plant. So we don't have any limitation. And I will say that although some customers are starting to be more open to host these platforms in private cloud, obviously with the internet secure, as you said, there are still a lot of regulatory and compliance requirements that require install the infrastructure part on-prem, and this can be done perfectly.
Anything to add, Rudy? Especially in terms of like the security and reliability of a kind of on-prem edge kind of installation between Barbara and Stratus.
Sure, and I suppose where I'd go with it is really, no two applications are ever exactly the same, and some customers need to do the entire loop on their own, right? So we see some customers that go all the way to saying, hey, I'm going to deploy high performance compute and train my own models and do everything in-house and not use any public cloud. And the beauty of what the combination of a good orchestration platform along with an edge computing platform provide for you is that the experience can be exactly the same, whether you're developing this in the cloud, deploying from the cloud, or developing it fully on the edge or in a hybrid model. Barbara really helps make it seamless for you so that the experience is the same, no matter what the architecture is that you need to deploy. Everybody's going to have their own security considerations and encryption and requirements. So really, that's the beauty of what a orchestration platform like Barbara provides, is that user experience.
Yeah, I agree 100%. There's a few more questions that are coming up, but we want to move to this the second part of our webinar. Please keep your questions coming. We will try to answer them before the time's up, and if not, we will answer them personally via email to each and every one of you. Now I'd like to hand over the webinar to my colleague and collaborator, Miren Zabaleta, who will guide our two subject matter experts through the second part of our webinar today. Over to you, Miren.
Well, thank you, Jay. Fascinating insights there. Now, we're going to dig a little deeper into what this emerging technology achieves and involves for businesses that want to embrace it. So we have a few questions for the panelists. Why is edge computing gaining traction now? David, can you share some data and trends that highlight this growth?
Yeah, and there was, by the way, a question from the audience that was saying, what is holding energy utilities to use edge computing? That is very related to what you are saying. Just very briefly, for the energy utilities, I think what is holding them more is the regulation. Okay, this is a regulated environment, and all the changes need to be done very carefully. And I will be happy to go more in detail on this, but in the energy utilities, especially in the distribution world, is going little by little, although most of the DSOs are already preparing their RFPs and RFQs to be launched in end of 2024 and 2025. But in some other environments, like the industrial or the process manufacturing, this is becoming a real trend. And actually, based on a Citrix study, more than 25 of companies in the UK have already moved half of their workloads to the edge. So this is a tendency. You may be asking why companies are moving to the edge. The statistics that I have here is that 40% are moving this due to cost. So the cost of the cloud, the cloud made a lot of promises time ago, and is very good for certain type of environments. But when you are generating like thousands of data points per second and tags, the cost is not affordable. So 40% of companies is moving to cost or scalability. 40% are moving due to privacy or security concerns. As I said, the orchestration platform can be fully on-prem, and the edge can be fully hosted by a company, so then you diminish any privacy and security concern. And 20% are moving because of latency or reliability. So cost, privacy, and security is making many industrial companies to start considering edge computing as the right infrastructure to deploy some of their digitalization processes. In terms of sectors, I think from what we are seeing personally at Barbara and Stratus, but also through the analyst, the sectors that has more distributed assets are the ones that are more electable to have edge computing. Like, I think the top sectors are the energy, including not only electric utilities but also oil and gas, and also manufacturing. And there is a statistic that 60% of the energy utilities and manufacturing companies are expecting to deploy edge computing by 2025. And last but not least, the penetration of AI. I read the other day that 50% of the edge computing use cases in 2026 will be having AI components. So I think this is coming really to be here very quick.
Well, thank you very much. Very interesting. Rudy, Stratus is about ensuring the continuous availability of business critical applications by delivering zero-touch computing platforms. Can you expand on that and tell us how Stratus achieves zero downtime and zero data loss?
Yes, absolutely. So really, I'll begin with two key points. It's a combination of technology and services. For over 40 years, Stratus has been focused on developing and deploying IT infrastructure into OT environments that cannot afford any data loss or any downtime. And we do that from a technology perspective by developing systems that are redundant. So all of our hardware is redundant in nature. However, it is transparent to the application. And what I mean by that is that the applications don't really know that the hardware is redundant, and that's part of the IP that Stratus provides. And this is key for the edge environments and the OT environments, because when you have software-based redundancy solutions and clusters, it can become very complex. And although it's feasible in data centers where you have many IT professionals who know how to work on those systems, at the edge, many times we don't have that expertise, or really any of the people on site who know how to work on it. So Stratus provides a combination of this technology, which is redundant and transparent to the application, along with service models that lend themselves to be very easy for the edge. And what I mean by that is, hey, look, hardware fails. We know hardware fails, and part of what Stratus does is we automate the processes required in order to replace this hardware. We make it really simple with color-coded cables to where anybody in the field can remove a failed node, install one, and many times they do that without anybody even knowing that the hardware failed in the first place. We're monitoring everything remotely and replacing hardware before the customer experiences any downtime.
Okay, super clear. David, edge management and orchestration tools. What are the main requirements companies should consider when choosing one?
Yeah, I like you make this question because it's very related to what Rudy was describing before. So the industrial world has a very different requirements than the IT world. And there are several edge management and orchestration platforms coming from the IT, coming from the open source, like let's say, for example, Kubernetes, which is great to implement edge management and orchestration when it is related to an IT infrastructure. But Rudy was speaking about zero downtime, and zero downtime is zero downtime. I mean, it's not 100 milliseconds. It's not, and this is very complex to achieve with some of the orchestration platforms that are out there. So I think that when industrial companies select an edge management and orchestration platform and technology, it needs to be something that is very, very specific to OT, and there are not many out there. And unfortunately, many companies are starting to try to do their edge deployments using these Kubernetes and some other let's say cloud-oriented tools, and it's taking very long, and they are failing at the end. And I'm not saying, of course, Kubernetes will never be prepared for OT. We're following very closely what Kubernetes is doing, and we are incorporating some of the features, and this is a great partnership. But there are some gaps in what some of the general or generic IT orchestration platforms present that needs to be filled when it comes to OT environments. And the second requirement that I will be very important is the user experience. It is very important that the user experience is similar to what the industrial people is used to. So industrial people, they normally are very used to program PLCs with graphical connectors, with boxes, with arrows, with these type of things. Don't expect an industrial engineer to enter into a black command line interface and connect the GitHub repo, download the GitHub repo, and provide this type of IT user experience. So with Barbara and Stratus, everything is, let's say, industrial oriented, and we focus our user experience on the way that the people can focus on creating the policies, the right policies, creating the right data flows, creating the right data logics without having to have an IT knowledge. So high availability, zero downtime, and zero touch deployment. So we can speak about two zeros: zero downtime, zero touch. And with these two zeros, I think the edge management orchestration tool will be very useful for industrial environments.
Okay, thank you so much. You mentioned high availability. So this is a question from Rudy. How is Stratus different from other high availability cluster solutions?
Sure. So I'll really build on what David is mentioning there, right? And it's that zero touch and zero downtime user experience. There are other clusters that you can develop and deploy. However, Stratus has for over 40 years just been focusing on developing systems that are maintainable and supportable by people in the OT environment. So to David's point, right, we're not going to have a lot of those IT professionals in the edge and industrial environments. And so what we do is we automate a lot of the IT processes required, and we make it completely transparent to the application. So, for example, when something does fail on a Stratus system, the very first thing that happens is a system will show up at the door, and one of the things the users call us and say is, "Hey, I didn't order a replacement piece of equipment. What is this showing up for?" And we say, "Hey, actually, you had a failure. You don't know you had a failure," and it's as simple as a physical replacement. When you compare that to traditional IT high availability clusters, where one, you had a failure because your operations experienced it. Two, you need to go and you need to buy new hardware. You need to install new software, take backups, get all these images, synchronize everything. There's a lot of IT functions associated with that. And we know that our users don't have the expertise, time, or experience really to do that. So it comes down to the user experience and how we develop our products and our support models.
Okay, thank you so much. One of the main challenges when building an infrastructure is calculating the return on investment. How do you assist companies with this specific aspect? And this is a question for both of you.
Yeah, I can start and Rudy, you can build on that. So one of the things that I will say is that many companies are only taking the return of investment considering the use case and one use case. And this is a good thing. Like we are providing, for example, edge management and orchestration in water treatment plants, and they are saving a lot of chemicals by predicting the amount of chemicals that are being used. And with that, companies are saving like $300,000 per plant. So this is the one use case ROI. What not all the companies are doing is considering edge as an infrastructure. So if you consider edge as an infrastructure, the ROI keeps increasing and increasing and increasing with each of the use cases that you put there. But there is one very important point, which is the TCO, the total cost of ownership for managing this edge infrastructure. And this is a very important point, because if you don't consider this from the very beginning, your revenues and your ROI can be perfectly eroded. So I had one good story, which is in one of those water plants, we were doing the ROI, and then someone said, "Have we calculated the problem of sending people to the field if the infrastructure is failing?" And we calculated that with just one failure of the infrastructure, for example, if you have like a security vulnerability that you cannot patch and you need to send to all the plants one person to patch this vulnerability, just with this single problem, the cost was over 3 million. So no matter how much revenues you're having, how much cost savings are you having, if you don't consider the platform manageability and platform maintenance, the total cost of operation of the platform could be really, really high. So what I will recommend, and what we do always with companies, is to calculate the TCO of managing the edge infrastructure, and this is very, very important. Don't know, Rudy, if you agree.
No, I agree completely. Really, many times when we're looking at deploying a project, we look at the ROI and the total cost of ownership, and many times it's one department, right? Maybe it's your cybersecurity department needs to deploy a cybersecurity solution, and then it's just a cost, right? Maybe there's no return associated with it, or maybe it's production wants to deploy some sort of solution to help you optimize your process. Whatever it is, right? There's always one justification for it, and to your point, when you start looking at it from the perspective that you can consolidate a lot of these workloads, you can bring multiple departments together and give them a single place that they can launch from and control and impact the edge, then the total cost of ownership equation begins to compound on itself, right? Hey, you deploy a solution for optimizing maybe your communications networks, right? And then you realize, hey, to your use case, I've got a vulnerability with cybersecurity. As long as you have a good orchestration platform out there, you then now begin to solve these problems with software, with a software-centric approach. So you can develop these solutions and remotely push all of this out to the edge without having to do truck rolls, and more specifically, all of the associated costs with deploying a new appliance in the field. When you bring the data center to the edge, you now can take advantage of a lot of the tools that IT has developed in order to solve problems in a software-centric manner. And really, that's where we're seeing a lot of customers do two main things, which is, one, consolidate all of those workloads, but more importantly, it's bring their teams together, right? It's that collaboration between your IT teams or your traditional IT functions and your OT teams, and bringing them together under a single platform. while still maintaining the supportability from the appropriate team members. And what I mean by that is this doesn't mean that now your OT team has to be responsible for your cybersecurity application, or that your IT team has to be responsible for your SCADA deployment. You still separate that amongst your teams so that the appropriate members support their applications, but you give them all a place to deploy these solutions in a software-centric manner.
Thank you very much. And finally, what advice would you give to companies that are considering starting an edge computing project?
Well, that's we could be here for hours, but yeah, I think we mentioned some of them. So the obvious first one is identify a clear use case to start developing the edge infrastructure based on one use case. But I will say that many companies have already identified this use case, or both Stratus and Barbara can help identifying these use cases very quick with some of the reference that we have out in the market. But then as a second stage, I will recommend companies to create the infrastructure requirements and look for the edge as an infrastructure, not as something that can only host one use case. So if you need just one case, maybe you just can put the traditional PLC and whatever. But we need an infrastructure that can scale, that can host more applications using software PLCs, using containers, using software infrastructure. And for that, you need to create an edge infrastructure the same way that you create a cloud infrastructure. And for that, we help normally companies to launch RFPs, to search in the market, to do market analysis. But you need to contact the right infrastructure providers and don't try to do everything in-house, because open source is today all over the place. IT is evolving a lot, and many companies think that creating an edge infrastructure is a one person task, like putting a computer, putting whatever operating system, putting an MQTT broker, and that's it. But no, it's a very complex task that we've been developing for years now to make it zero downtime and zero touch. And this is something that Stratus have been doing for years, as well as Barbara, and we can provide an infrastructure out of the box, and the return of investment will be much higher than doing it in-house. So I will say these two very important advices: focus on use cases, and if you already have the use case, focus on selecting the right infrastructure, and don't develop the right infrastructure, because that will end up in a lot of years and probably a project that will have a lot of hidden costs.
Sure. And where I'll go with it, Miran, is to think long term, right? And what I mean by that is many times, and I'm speaking to the IT users, right? Many times we're thinking 1 year, 2 years, 3 years is the life cycle of our projects. And really, when you start looking at OT and industrial environments, we're talking 8 years, right? And so think about what this solution, what the problems are that you're going to be trying to solve 8 years from now, what it's going to take to support your applications and your solutions for 8 years, right? And when you start looking at that from a bigger picture, that's going to go to one of David's points, which is, what are the other applications that I'm going to need to deploy? In 4 years, what are the applications that I need to deploy? And in 4 years, the problem you don't need to be solving is replacing legacy hardware already to continue to support the application that you deployed today, right? What you need to have is an infrastructure that's there in place, that's ready to host your application. So think of the longer term solutions that you're going to need 8 years down the road, and then think of how you're going to support them. That's been key to what Stratus does, right? And of course, to connect it back to what we're doing, we know that our users cannot be on 3-year refresh cycles. A lot of customers that are on 3-year refresh cycles can never get through their entire legacy before the first one they deployed is already out of date, right? And so we know you have to support it for the long term, and you need to be thinking about that from a use case perspective and from a technology selection perspective. I could not stress enough how much you need to think about that from an orchestration platform perspective, because without it, you're still doing truck rolls.
Okay, very, very interesting. Well, thank you very much to both panelists. We do have some questions now from the audience, so let me read them. This is referring to the Rudy's, the use case you presented. He says, "Hi, I'm assuming that the historian is hosted centrally. Is it hosted on the IT data center or in the cloud? What were the security challenges that you encountered to transfer the data?"
Sure. So in the use case that we were looking at, we began with historization data and historians per unit. So every unit had its own local historian, right? And those historians were actually then feeding up into a centralized historian that was into the cloud. This existed prior to our project, right? So we didn't deploy this specifically for the project. And I will say that one of the things that really enabled our project was, one, that they had the proper security protocols in place. So they were doing encryption, they had all of their firewalls in place. They made sure that data was only flowing out and could not come back in on those same networks and connections. Right. And so it was read-only data going out and going into the cloud. And because they had that, that really enabled us to do all of the data center work that we needed. But yeah, I guess to answer the question, it was a hybrid model that had both centralized data that was synchronizing with the historian at the cloud.
Okay, thank you so much. Another question by Luciano. It says, "What kind of hardware Stratus model and acceleration resources Barbara is using at the edge?"
Yeah, but very quick, and we're happy to deep dive this offline because we're reaching to the end of the call. Barbara is hardware agnostic, so we port our platform to different hardwares, and we can work with both with GPUs as well as CPUs. We are mostly working with Stratus CTC Edge, but the reality is that we're hardware agnostic. So whatever Stratus hardware that you're using, we can definitely use Barbara orchestration and provide the full benefits of the combined solution.
Okay, very, very straightforward. Thank you so much. Well, thank you all for attending. But before you go, can I ask you to take a moment to complete a brief survey about today's webinar? We have just posted it, the link in the chat, but we would really appreciate if you can actually fill in for us for our next upcoming webinar. So, well, thank you so much. Just on the spot, it's almost 3 o'clock. And well, it's been a pleasure to run this webinar together with Jay, and happy to assist you. And, you know, email us, please email us, and we will respond to you straight away. Thank you so much to everybody.
Thank you very much. Thank you. Bye-bye. Pleasure.
Bye-bye, everybody.